transposition rules that we have matrix. Okay, as I said earlier, we could use an example for A could be like a normal matrix, maybe this type of matrix, just a normal matrix. It could be any type of matrix that we have, maybe a 3, 5, 6, 4. It could be maybe something like this, a 3 by 3 matrix. That's A. So this is the rules. We could have A transpose of transpose. This will give us that matrix. There's nothing that we can add to it. It's like it's going to cancel out the transposition of the first matrix. Okay, and if you say we have a constant times a matrix like this, what we will get, the constant is going to be there, and then we're gonna have the matrix transpose. This is what we will get as solid. Now next, let's say we have something like this. This is the same as if A and B are matrices. We know that A and B both are matrices. Okay, and okay, it's a constant. That's why we didn't add it there. It could be a constant or number or something like that. So now this one we got ourselves a two matrices, so it's gonna be A transpose plus B transpose. That's what you see. Okay, there's more to it. Now we have this condition. If this is just a condition, okay, if a transpose of a matrix, it may happen equal to that matrix. Okay, now we say that matrix is symmetric matrix. Okay, that's what you see, and we know this is just a matrix. And what is a matrix constitute? It's actually constituted with column and row. That's why we see ij. Ij is just column and row. Okay, and what you should know, ij is just column and row. If I can just say this is a row and j, this is column. Okay, because of these rules that we just define what is inside that matrix, we could represent it as this matrix. We could swap the row. So if we swap the row, it's still gonna be equal to each other because of so we can take a matrix and just change its position. We're still gonna get that matrix, like it's just inequality. For example, if it was A, B, C, D, E, F, we add something like this, it's the same equal as A, C, E, B, D, F. This is what we're trying to tell you from what you see here. Okay, and then there is one other rules for multiplication. Okay, and the rule for multiplication is as follow. So okay, this is also very important for you to know. Let's say matrix C, matrix A times B. Remember, you should know that C, A, B, those are matrices. Okay, the matrix that you see here, so let's say j and I, or the size of a matrix. So for this, I could represent this matrix as 3, 2 times 3, and this one will be 3, it's actually 2 times 3, and this one will be 3 times 2, or maybe the other way around. Okay. Oh, I think I just made them. Let me just swap them as it should be. 3 times 2, so row times column, and then here it will be row times column. That's what you see. And in a representation, I'm going to use some quotation, like saying, like, remember I said that this is I and this is j, row and column. So this is j and then this is I. So I say that this is actually I just swap them around. It's gonna just, let me just correct this. So I and j, this is row and column. Okay, now I'm going just to use some quotation. Maybe I'm going just to represent row by m. You can use any alphabet you have. Maybe column by n, and maybe I could also use I could use p for row, and then r. Just bear with me. This is just to give you an example. I'm going to apply them in this example we have. Let's say, for example, this is the equation we have. Multiply matrix that you see here. Okay, what you should know is, if A is the matrix of this size, okay, m times x power, and P times R, okay, there is a certain condition for us to multiply those two matrices. Okay, and what you should know is the answer to this matrix, which will be based on m times that is what we're going to have as size. So meaning the first one is what we're going to get on the size of the matrix. And then let me see if I do have another color I can select. The n, the r that you see here is what we're going to get there. So it's actually r that I was trying to, so this is r, so that's what we're gonna get as size. Then the multiplication condition, for it to work, for us to have this multiplication possible, those two has to be equal in terms of size. So if n equal to 2, this one also has to be equal to 2. So then you can perform the multiplication. If they are not equal, you can't multiply those matrices. There's no way that you can multiply them. Okay, pay attention to what I'm saying. There's also a way for you to, you see, for example, if I say this is m, so you can see you can swap around m. Okay, you can swap around m and n, so it can be n and m. Okay, just to give you an example. So this matrix you can swap them around, but now what you see here is just to give you an idea. So this, if this one equal to 2, this one also has to be equal to 2. If we have two columns, so we need to have 2, p and n has to be equal in size. Okay, then if for example m equal to 5 and then r equal maybe to 3, so your final answer will be 5 times 3. So that's what you see. It will be your row and column. That's what you see there. That's what I'm trying to give you. So in our case, this is I, this is J, and this is I, this is J of the second matrix. Just to give an idea of what you will get. Okay, and lastly, there's one rules for multiplication. This matrix, the question is it equal to this matrix? This is a random question I'm asking you. The answer to that is no, they can't be equal. No equality. So if you are asked if you multiply two matrices, they will be equal to the reverse of those two matrices. No, you're not gonna get the same answer if you solve those matrices. So not equal. Okay, and then there you have it. This is all I wanted to give you in one shot. Okay, we started from here, transpose, and then we move to multiply matrices.